Hi everyone. In this lecture, we will stream data from Twitter. As you can remember, the task of the Twitter to Kafka service is to get the streaming data from Twitter and put the data on a Kafka topic. In this lecture, you will implement the first part of this microservice, streaming tweets from Twitter. To implement this, you will use Twitter4j, which is a Java library to consume Twitter API easily. Alright, let's now go to Twitter4j site and see how we can configure our application to start reading Twitter data. Here we see that we need Twitter4j properties file, which includes OAuth keys and secrets for authentication. Let's put this file into our project under Resources folder. Now we need to obtain these keys and secrets from Twitter. So let's go to Twitter Developer Console and create a developer account if you don't have one. During application creation, you need to specify a reason where you can say that you want to use this data for a course on Udemy. You can use the Create App button to create a new application. Then it will require to confirm your email to get the keys for your application. After your application approves, you can go to Developer Console and get your consumer key and secrets, as well as the access token and the secrets in the Keys and Tokens section. As you can see, it is advised to keep the keys for later usages on a safe location, as you won't be able to see them in 2021. You can regenerate or revoke your access token and secret also here. After getting these 4 values, let's now put these values into the Twitter4j properties file in our application. Note that I started getting some comments in the QA section about getting a Twitter developer account. Twitter is making it a bit more difficult to get a developer account. So I have added the possible responses to the questions that you will get from Twitter. Also, there are some new changes in the Twitter developer account process. Now you can get an essential access by default, and to continue streaming data from Twitter in this course, you will need to apply for elevated access. Please open your Twitter developer dashboard and apply for the elevated access for your account. In addition to this, to create a new developer account on Twitter, you will be asked to provide a valid phone number and do a validation using this phone. However, please note that you don't need to wait to get a Twitter account to continue with this course. As mentioned, Twitter data is just an example input data, and you can use any streaming data, even a mock stream data, to continue with this course. And in the next lecture, you will implement a mock streaming data that you can use to continue with the rest of the code while waiting an approval from Twitter. Great, we have the configuration done. Let's now create a listener to start streaming Twitter data. We can check the examples on Twitter4j site in the streaming part. We could actually implement status listener interface directly, but I don't want to implement all the methods, so I will simply extend status adapter class and then override only onStatus method. So let's create a new package called listener, and then create a class here called Twitter Kafka Status Listener. And simply extend the status adapter class from Twitter4j. Then we will implement the method onStatus to write some logging inside this method for now. So let's create a logger here using logger factory class of SLF4j. And log a message in info level. We will print the text property of the status class here, where this status class is again a class from Twitter4G library, and it represents a Twitter object. Let's then annotate this class with component annotation to make it a Spring managed bean. Note that all classes that annotated with component annotation will be scanned and loaded as Spring Bean at runtime. There are also more specific annotations like controller for APIs, service for business layer, repository for data layer, and configuration for config classes. In the end, all these annotations will be scanned and loaded by Spring at runtime. Now I'm going to create an interface called Stream Runner. Let's first create a package called Runner. And then create this stream interface with a single start method, which will throw a Twitter exception and has a void return type. Then we will implement this interface with Twitter Kafka Stream Runner class, which will be under impl package. Let's first implement Stream Runner and override start method here. And then annotate this class with component annotation to make it a Spring managed bean. Alright, let's inject the Twitter listener and the config classes we created previously using constructor injection here. Let's also create a global Twitter stream variable, which is a Twitter4G library class again. And then we will start implementing start method by first creating a stream using Twitter stream factory getInstance method. And then we simply add the listener we just injected into this Twitter stream. Then first I will extract the keywords as string array from the configuration object using toArray method on the Twitter keywords list object. And then I will create a filter query from Twitter4G library with the keywords array. Then we will simply add the filter query to the Twitter stream. Here let's also create a logger using logger factory to log some messages, and then write a simple info message here, specifying that we started filtering Twitter stream for the configured keywords. We can actually create a new method for this adding filter task, so I will refactor here and create a method add filter and extract this part as a new method. I will also create a shutdown method and mark with predecessor annotation, and then close the Twitter stream here. Let's also add a bit of logging after checking stream is not null. This method will be called before the bean destroyed, that is before the application shutdown, so that we will be sure that stream connection will be closed prior to application close. Note that Spring beans are created with singleton scope by default. That means there will only be a single instance for each bean, and when you inject this bean, it will use the same singleton instance instead of creating a new instance. If you define a Spring bean with prototype scope instead, then for each injection of bean, Spring will create a new instance. So it will not be a singleton anymore. And one important thing about predestroy annotation, Spring will not call methods with predestroy annotations when a bean is in prototype scope. Alright, finally, let's inject the runner we created into the main class and call the start method in the run method. Let's first inject the stream runner to application class by adding the stream runner into the current constructor. Then we will call the start method, and this way we will trigger the streaming logic on application start, and it will listen Twitter messages continuously for us. Alright, let's now run maven install command to see we have a successful build and to install dependencies. Whenever you add new dependencies, you can run maven install command to install the dependencies from maven repository. Maven clean command clean the files and directories generated by maven during its build. And the install command will build the project and install it in your local repository. We can now run the application, and we should see the tweets in the console if everything works correctly. Please note that this microservice will be used as the command component in CQRS pattern. Remember that we have Kafka as the event source in our architecture. Twitter to Kafka service, stream the data from Twitter, and put on a Kafka topic. We can call this data as events, and we will send the events to the event store, which is Kafka. In the coming lectures, I will consume this Kafka topic and put the data on Elasticsearch using another microservice, Kafka to Elasticsearch. And later, I will implement the query components to complete this CQRS and event sourcing architecture. In Elastic Query Service on lecture 44, we will have a query component that will read the data from Elasticsearch. That data is actually the data in the Kafka topic that is populated with events here in the Twitter to Kafka service. But instead of reading the data directly from Kafka topic, we will use the data on Elasticsearch that is populated with Kafka to Elastic service. And the query component will read the data or events from the Elasticsearch. This will be a much more effective way of querying as the Elasticsearch is built for querying data effectively. So the write and read parts built differently in CQRS pattern to separate the concerns and do the operations effectively. This will lead to an eventual consistency as opposed to strong consistency, because there will be a small delay between write and read operations. But this is not that important if you don't do real-time operations, and having write and read parts separately will allow you to implement and use the different parts much more effectively. Here on the screen, you see a nice example of eventual consistency with a comic from Pascal Jauselin. While saving the little cat, our hero Imbutable causes a small synchronization issue. But with a small delay, everything settles to the correct state with eventual consistency. Alright, great job so far. I will see you in the next section.